Good morning, fifth graders. Hey, 5B. Hey, 5A. Hey, I miss you guys. I'm sure that you are missing school too. Well, you're probably just missing like coming together with your friends. You're really not missing school. But here we are on e-learning day 3. I do want to encourage you all to make sure that you are completing your measuring up assignments. You need to make sure that you're getting on and that you're logging in. If you forgot your username and password, then please email me at milam@hsabelmont.org. Okay, milam at hsabelmont.org. MILAM. Okay. All right. I did reach out to a number of your parents last night, just encouraging you to stay the course because we're going to have a lesson a day. So we just want to make sure that you guys are doing it, okay? Don't forget what Dr. Mom said about you have to have so many hours that you logged in and that you were online and things like that. All right, lesson 18, objective, relate decimal and fraction multiplication. That is our objective. And really, this is just the same lesson. It's just more practice with yesterday's lesson. The one thing though we are going to add is the unit form to this. So we're going to do it with the standard algorithm, but we're going to use unit form language so that you can see, again, the connection between the two. Let's start with the application problem. We'll let you get to it in your book. You should already be there. And let's take a moment and do this, okay? Uh, this should be pretty straightforward from yesterday's lesson, but let's dig in, okay? Don't forget that we're in Module 4 and we're on Lesson 18. An adult female gorilla is 1 4/10 meters tall when standing upright. Her daughter is 3/10 as tall, meaning 3/10 as tall as the adult, their parent. How much more? Now that's probably an indication of subtraction here. How much more will the young female gorilla need to grow before she is as tall as her mother? Well, we actually need to find out how tall the daughter is because it doesn't say that she's 3/10. It says that her daughter is 3/10 as tall. So that means that we've got to actually find it. The beginning sentence says that the adult is actually 1 4/10 meters tall. All right, so what are we going to do? We're going to take 3/10 of 1 4/10, and I hope that you're okay with me writing this the way it is right here. Okay, so then that's going to be equal to what? 3/10 times, and are you okay with me writing this as 14/10? Remember that this 1 here, I can write this as 10/10. Whoops. 10/10. And that's plus, plus plus your 4/10, okay? All right, which is going to give you your 14/10. So what is this answer? This answer is 42 hundredths, because I'm just multiplying the top and the bottom. So that is how tall she is, 42 hundredths meter. Okay, so it says how much more will the female gorilla need to grow before she's as tall as her mother? So that means we need to subtract the two. So this is in fraction form. This is in decimal form. Why don't we change this back into decimal form? So this is 42 hundredths. So you know we're going to write that as 0.42. All right, and I've got 1.4, so I'm going to line up the decimals. This is good practice for us here because then how do I subtract this? Well, I've got to add a 0. So if you notice what Dr. Milam did, I lined up the decimals, then I added my 0. All right, we're going to regroup from here and add that here. And then we're going to regroup again, and that becomes 13. We're going to add that here. You know, this is so wonky, right? So then that becomes 8, and this is 9 right next to it. And then where's my decimal point? Ah, there it is. So it's 98 hundredths, okay? That is how much more she'll need to grow before she gets to her mother's height, okay? All right, so that's it with the application problem. Let's go on to our lesson for today. Okay. As I did yesterday, I'm going to take a few minutes to do a few problems for you to get you started. I've got a number of problems here. I don't think we're going to get to all of them because I don't want this video to be too lengthy, but let's just get started. So here's our first problem. So we learned from yesterday really how to solve this. So this is 3 and 2/10. This is 2 and 1/10. So 3 and 2/10 looks like this. And we're going to multiply that by 2 and 1/10. This is not new. This right here is not new for you, right? So this is 32/10. I hope you're okay with that. 32/10. Because this is, you can do it two different ways. This is 3 times 2 plus, 3 times 10 plus 2, which is 32. Or we could think of this 3 as 3 holes, right? 3 holes. And each hole is how much? It's going to be 10 tenths. So I've got 10 tenths here. This is actually good practice for us to use our language. This is 10 tenths here, here, and here. And so when we add that together, then we get 30. But then we've got 2 more up here. And so that's where the 32 comes into play. Okay, and I'm just going to move this. I'm just going to move this over here. So we have a little bit more room. All right, plus 10 tenths. And as I said, that 10 plus 10 plus 10. Remember, you're adding here. So this is 30 tenths. And bear along with me for those who may need this, okay? And then now we're going to add the 2 tenths, okay? So all we did was really convert. We converted from a mixed number to an improper fraction. That is not new for you guys. You know how to do this, okay? Times, and I hope you're okay with me putting 21 tenths here, okay? All right, so then I'm going to do 10 times 10 we know is 100. And then what in the world is 32 times 21? All right, well, let's do that down here, okay? So 32 times 21. This is not new for us. We know how to multiply this. 2 times 2 is 4. 2 times 3 is 6. Remember, I'm going to put my placeholder of 0 in there. And so this becomes 672. 672. So that means that this is 672 hundredths, okay? Which then gives us, how many hundreds are in 672? There are 6 of them. What's left over? 72. And then my final answer is 72 hundredths. If you notice that Dr. Milam put that in there, and that decimal point should not be in there at all. Okay? All right, because we're writing that as a fraction, or now I can write this as a decimal here. Okay. All right. What is new is writing this in unit form. So now let's go back and let's write this in unit form. So what is 3 and 2/10? We decided that that was 32/10. And so right here, I'm going to write 32, and I'm going to write the word tenths. It's going to be a little tricky for me. 32/10, okay? So then this is what? This is 21/10. Okay? All right, so this is really the same thing that I did down here at the bottom, except for now I'm writing it with my unit form. So this is 32/10, this is 21/10, and we're going to multiply the two. And so what do we get? We get exactly what we got before. So we've got 32 here. Here's my placeholder of 0. I've got 4 and 6. So this is still 32/10, but now this is 640 hundredths. And so when I add these two together, what do I get? I get 672 hundredths. I'm not doing anything different than what I've done before, except for I'm just writing actually the name of these numbers out, hundredths. Okay, so then how do we represent 672 hundredths as a decimal or in decimal form? And then that is the answer. Okay, so it's really nothing different than what we've been doing, except for now the problem set is going to ask you to write out the name. And yes, before you even ask, yes, I do want you to get some practice writing out the name, because I think that if you do that, it's going to help you keep up with your answers. Okay, so I want you to practice it for a couple of them. Okay, and I'll tell you which ones to do it for. Let's do another example. I'm actually going to go down here and do this example just because there are different numbers, okay? All right, here we go. So this number is what? This number is 2 and 6/10, okay? So we're going to multiply that by what? 4/10. I really like this way of multiplication. Dr. Milam learned the old way. And so we had to take out the decimals, multiply the numbers, and then the number of decimals lets you know what your answer is. And some of your parents may even show you that. But you show them the new way of multiplying decimals, okay? So 2 and 6/10 is 26/10. Don't forget, it's 2 times 10 plus 6, or you could think of this as 2 wholes, 1 plus 1. And then this is 10/10. I'm not going to finish this because you can look at the example from earlier, okay? But just to give you an idea of what we're doing. And this is times what? 4/10. And so right here is where I'm going to write my language. So it's 26/10. And if you notice, I'm going to do this side by side. I'm going to try a little cursive, makes it a little quicker for me. Okay, 26/10, and that's times 4/10. All right, and so what do I do? So 26 times 4 and 10 times 10, so that's 100. 6 times 4 is 24, and we're going to carry the 2. And then 4 times 2 is 8, plus 2 is 10. All right, so we should get the same thing here, right? This is 4, 2, And so what does this become? Now it's very, very tempting. It's very tempting. Let me get rid of that. Hold on just 1 second. It's very tempting to say this is 104 tenths, but immediately what do I have here? I have hundreds. So be very careful, ladies and gentlemen, that you don't bring down this particular um, language for this number because it's no longer tenths, it's hundreds. Okay, all right. And so how many hundreds is in 104? So there's one, and then what's left over is 4 hundredths. I hope that this makes sense. Just wondering whether or not you need one more example of this. Let's do this problem down here. Oh, I'm sorry. Let me just finish this. 1 and 4 hundredths. Okay. All right. Same thing here. 1 and 4 hundredths. All right. I think Dr. Milam is going to keep going to the problem set now. I think we're going to go on to the problem set. If you notice here, just as well, is that they wrote it here as a fraction. They took each decimal, wrote it as a fraction. So 2 and 3/10, they went straight to 23/10, 18/10. If you see it, you can do it. If not, if you need to do the intermediate step of writing this way, then you can do that. Whatever is going to help you to complete these problems, go ahead, because there's more than one way to do it. If you notice what they did, they just went on and multiplied. They're also showing you the standard algorithm here. They're bringing the language along, okay? Same thing here. So they didn't do this part on this one, so let's go ahead and do that. So 2 and 3/10 is the same thing as 23/10. And we're going to multiply that by 9/10. Okay, so then that becomes 10 times 10, which is 100, and then 23 times 9. Oh, multiplication facts. 9 times 3 is what? 27. Carry that 2. 9 times 2 is 18, plus 2 is 20. So now this is 207 hundredths, which is how many hundreds are in 207? There are 2 of them. And what's left over? Watch this. 7 100ths. Look at that. If the intermediate step that Dr. Rome did not write down was 2, and what was left over? 7 100ths. I went straight there. Here I would have, let's see, I would go straight there, this particular case. And if you notice, once again, my language is hundredths. Okay? All right. Let's see. I think you may have the hang of this. Anybody needs to see another? Let's do one where we're going to have thousands. Okay. So let's go down here. Okay. I'm going to do this one. Okay. So this, how do I already know? Yeah, this is a teaching moment for me. How do I already know that I'm going to have thousands as an answer? Well, I've got two decimal places here. I've got 1 here, so probably by the end, I'm going to have 3 decimal places. So I already know it's going to be thousands, okay? So now let's rewrite this. This is going to be what? I'm going to do both of these here. So it's 6 and 600ths. How do I know it's hundreds and not tens? Because I've got 2 decimal places here, and the first one is tenths, and then this one's hundredths. Okay, so that's how I know. Times what? 2 and 8, careful. 8 what? Tenths. Look, you can tell already 100 times 10 is 1,000. We see that already. So this is 66 hundredths. Hope you're seeing some of the patterns. And this is 28 tenths. So we already established that the bottom number was going to be 1,000. So now let's do 66 times 28. If you notice that we're not doing like 6 times 2, which is 12, and then doing 6 hundredths, we're not doing that, okay? We're actually converting, multiplying, and then putting it back in decimal form. So 6 times 8 is what? Smarty pants. It's 48. So 8 times 6 again is 48. And then when we add the 2, we get 52. All right, need my placeholder here. 2 times 6. Remember, it's really 20 times 6, right? Which is 120, or 12 in this case. And then we've got 13 here. And then we've got 8, 4, 8, and 1. So we've got 1,848 thousandths. So in this number right here, 1,848, how many thousands are in there? Well, there's only one. And then what's left over? 848 thousandths. This is just a side note. What if this number was like, let's see. What if this number was like 3,848? This is just Dr. Milam thousands. Guess what? How many thousands are in 3,848? Well, there are 3 of them. And then you have left over 848, thousandths. See the difference? Okay. So this is our answer. Let's make sure that we're writing this in our uniform. So this is 66 what? 66 hundredths. Little cursive for you. And then this is times 28 tenths. All right, that might work for us. Although I can't, it's hard to cross the T. Anyway, you get it, okay? And so we already know what the answer is, right? So we know that this is going to be 528, 528. And actually, you could write hundredths here. You could do that. And then 1,320, which gives us 1,848 thousandths. There you go. All right. Hope that this makes sense. I'm having a little fun here. You know that you can always rewind the video. Okay. So I'm not going to do this. I'm going to say that you can do the language, the around. Well, this one here, the directions here say you can go straight to the standard algorithm. So you can go straight to the standard algorithm with your description, with your uniform. So if you're going to do this straight to the standard algorithm, you must write this. Because what I don't want to happen is that you get to the end and you just say it's 192 or 192. You can't do that because that's not the answer. The answer is 192 hundredths, and that's very different. Okay? So if you're going to do the standard algorithm with just the numbers, you must write it with the unit form there. Okay? If you have any questions, you know how to get in touch with me. Let's go down here and do the word problems because I know that's always the killer. All right, let's do it. So Caroline buys 1 2/10 pounds of chicken breast. If each pound of chicken breast costs $3.70 or 3.70, that's how you say that in unit form. How much will she pay for the chicken breast? All right, so each pound costs this, right? So if I've got 1 2/10 of a pound, so I at least know it's going to be more than $3.70 because I have more than a pound. Well, let's see how much that is. So that means it's 3.70 or $3.70 times 1 2/10. Okay, so I'm going to go straight to the standard algorithm. I'm going to write this as 370 what? Tenths or hundreds? Better be hundreds because this is 3.70. Okay, so hundreds. If you notice, I'm writing my uniform language out. This is 1 2/10. So that means that this is 12 tenths. Now, if you're not sure if it's tenths or hundred, come over here and do the conversion because I don't want you to get it wrong. And then this becomes 370 hundredths. And then you can see that this is 370 hundredths. Go ahead and do this, 1 2/10. If you can't see it right away, that's okay. So that becomes 12 tenths. Be very careful. Be very careful. This is 10. This is 100. Be very careful. Unit form says that 1 2/10 is 12 tenths. When you're converting it from a mixed to an improper, you can think of it as 1 times 10 plus 2. Or as the 1 is 10 tenths. If that helps you. Whatever helps you. Okay? And then 10 plus 2 is 12. All right, let's finish. So 2 times 0 is 0. 2 times 7 is 14. Carry the 1. So 2 times, this is times, multiplication rather. 2 times 3 is 6 plus 1 is 7. Put my placeholder here. 1 times 0 is 0. 1 times 7 is 7. 1 times 3 is 3. What's my answer? So what is this? This is thousands, right? I've got 4 places here. So that means that this is thousands. Be careful. This is decimal multiplication. Okay? So you can use a standard algorithm as long as you're bringing this along. You have to do that because you may get to the end. And so it looks like she's going to pay $4,440. But that's not true. How do I write this in decimal form? It's thousands. So I can write this as what? Right, go ahead and write it in fraction form, if that helps you first. And then ask yourself how many thousands are in 4,440. There are 4 of them. And then what's left? Careful. That's a 0, by the way. Thousands. Well, how do I write this as a decimal? Well, it's 4 with a decimal, 444. Now, I'm going to leave that 0 off only because we're talking about money. So I don't really need it. So she's going to spend, remember we said that it should be a little bit more than $3.70, and it is. So it's $4. Well, let's get rid of that. $4. I can't write a dollar sign. This thing is so picky. $4.44. Okay. All right, should we do the other one? Yes, I like this one. So a kitchen measures 3 and 7,500 meters by 4 and 2/10 meters. Be very careful. Be very careful that you're paying attention. So you know Dr. Milam is going to draw a picture. All right, so that means that it doesn't matter which side for my picture, but I am going to go ahead and make this 4 and 2/10 meters this side, and this side is 3 and 7,500. It says find the what? Find the area. So we know that a formula for the area is, it's going to area is length times width. Length times width. So we're going to do 375 hundredths. Now, how did I know already off the top of my head? Well, this kind of gives it away here. What is 75? This 75 is hundredths. So I already knew I've got 3 and 75 hundredths already. So that makes this 42 what? Somebody answer it for me. And I know they're going to do it. Kamari. It's 42 tenths. All right, here we go. All right, let's multiply these two together. Ready? So this is 10, right? 5 times 2 is 10. 2 times 7 is 14, plus 1 is 15. And then bring down your 7. 4 times, oh, I need my placeholder. 4 times 5 is 20. Carry the 2. Did this already. 4 times 7 is 28, plus 2 is 30. Oh, don't die the death of multiplication. 4 times 3 is 12. Plus 3 is 15. Did Dr. Marlon do that right? Let's see. 4 times 5 is 20. There's my 0. Here the 2. 4 times 7 is 28. It's 3. 4 times 3 is 12, plus 3 is 15. All right, let's add this. We got a 0 there. 5 here. 7. Bring down the 5 and the 1. Don't forget that I now have to write this in my unit form. So this is hundreds, this is tenths. How many decimal places, excuse me, how many place values do I have here? Got 1, 2, 3, 4, 5. Oh, wait, hold on. So this would be tenths, this would be hundredths, this would be thousands, right? This is what? Oh Lord, this is gonna be 10 thousandths. Did Dr. Marlon do that right? Is that 10 thousandths? I believe that it is 10 thousandths. Yes, it's 10 thousandths. And if I did it wrong, you know I owe you a marble. It's 10 thousandths though. Okay, so that means that I'm going to write 10,000s underneath it. So how many 10,000s? Well, we've got 15,000s here. So that means that there's only one. So it's 1 and no, I actually think that this is wrong. Let's see. I have my let's see. I have my teacher book here. Let's see. Dr. Marlon, do that right. I did not do that right. Did I not do that right? Let's see. Oh, I did do it right. Oh, it is thousands. Ah, Dr. Marlon. All right, I owe you another marble. All right, I know that Brene is going to keep me honest here. So this is wrong. Hold on. Let's get rid of this stuff. It's just thousands. And let me just tell you, I should have known it right away because I just told you that the number of decimal places here really is our indicator. So I've got 1 here, I've got 3 here. So if I had 3 decimal places, then that means that that's only thousands, okay? And that makes sense. That's going to make sense in a minute, okay? I'll tell you why. So if it's thousands, then I've got 15,000. Look at that. So then this becomes what? 15 and 750 thousandths. Okay? And that's the area. That's why this stuff is a little tricky. It's a little tricky. So I went from hundredths to tens. I'm putting hundreds and tens together. If I'm putting hundreds and tens together, that gives me thousands. Okay? And so that means I've got 15. I got 15 and 750 thousandths. Okay? And that is the area of the kitchen. Woo! All right, let's do the next one. The area of the living room is 1.5 times that of the kitchen. Find the total area. Oh Lord. So whatever the kitchen is, it's 1.5 times. So that means we're going to take our 15 and 750 thousandths and multiply that by 1.5. 1.5 looks like that, which is really, I mean, it's 1 5/10, or you could think of it as um, 3/2. You could think of it like that. But this is the same thing. 1/2 is the same thing as 5/10. And I did that so that I could put it in decimal form. Okay? All right, so I've got what? Tenths, hundredths, thousands. So this is thousands. This is what? This is tenths. All right? So let's multiply. So 5 times 0 is 0. 5 times 5 is 25. I'll carry my 2 up here. 5 times 7 is 35. Plus 2 is 37. Put my 7 here. I'm going to put my 3 here. Is everybody with me? Still working on the 5. Let's recap. 5 times 0 is 0. 5 times 5 is 25. Here's my 5. Carry the 2. 5 times 7 is 35. Plus 2 is 37. So here's my 7 and my 3 is here. All right, now I'm doing 5 times 5, which is what? 25 plus 3 is 28. And put my 8 here and my 2 here. It's been a while since you guys did this. 5 times 1 is what? 5 plus 2 is 7. All right, got to put my placeholder here. Now I'm going to do the ones, and the 1 is just each number. So I'm guaranteed no mistakes. So there's a 0 from here. Here's the 5 here. Here's the 7 here. Here's the 5 here. Here's the 1 here. I'm going to add. Carry my 1. Carry my 1. Carry the 1. Got 2. How many decimal places do I hear? I have 3 here, 1 here. That means I've got 4. 1, 2, 3, 4. There it is. Okay. So I've got thousands and I've got tens. So this is what? This is tens, hundreds, thousands. This is 10. So I've got 4 decimal places. Where is that going to put me? Tens, hundreds, thousands, and then what? 10,000. And I can see that here. Got 4 decimal places. Tens, hundreds, thousands, 10,000s. So that's my number here. I mean my language here. 10,000s. Okay. So what is the answer though? The answer is this: 23 and 6,250 10,000s. It says what is the total area of the living room? It's in meters, and so this is your answer. And it didn't tell us to round up, but I'm going to go ahead and round up just because it just makes sense. And that's meters square. All right, ladies and gentlemen, that wraps it up. Don't forget to do your assignments. Don't forget to go back to Google Classroom and mark them complete. And until tomorrow, I'm thinking about doing something live tomorrow. We'll see. All right. Talk to you later. Bye.